Thank you. Thank you very much. Hello, everyone. And thank you, Amir. Thank you, Aggregate Intellect, for this organizing so much events. I'm just really missing it's a fantastic community. I'm since I left Toronto and now in Madrid. The Slack channel is my my solace. It's just like remembering all good memories. So thank you very much for having me and organizing all these. So. Yeah, so I have a really good privilege of being the last speaker. So we've heard all this good stuff about all aspects of the language models. And now I think you will find something new here. And that's where we want to basically connect an LLM with with mathematical model. I mean, financial model is just application here. But really the core part of this is that interaction. So we saw examples in information retrieval. We saw some of the code generation, problem solving, like with the pandas and all that. Now here is really the question is, can ChatGPT build a model of the real world and a mathematical representation of the real world, and then be able to simulate it and be able to tell us information about it. Now context is financial model, because financial models are simple to see and to model, to understand, and very important. So I will start with the motivation first of what's the goal here. So my educational background is in scientific computing. I did these type of models of crystal growth when I was doing my PhD about 15 years ago. So like solving a 4,000 differential equation in a three-dimensional domain, things like that, where you need to build a model to describe a complex physical phenomena. And then I moved to the data science field in 3 different companies as a manager, managing different data science team of different topics. But what I'm really interested in is using these mathematical models for socioeconomical systems. So answering the question of like how the economy works and giving people understanding of these models. This is one of the ways that we can improve, empower humanity to be more rational. One of the ways to be rational is to understand a situation, say, I can build a model of it, I can forecast, I can see how the system works. And transitioning or transferring a real situation to a mathematical situation, that's one of the key tools for being making more rational choices. Now, these models for finance is one of the areas where the least, I think, accessible for people. So we have lots of models for risk management, lots of models for trading, all that, but it's mostly used for making the rich richer kind of idea. Whereas, can we democratize that access to these models or the modeling so people can use it? So let's go in and jump into the concepts of the language model. So we see lots of these limitations. So Suhas, you made a great presentation on logical reasoning capability of the LLMs. But I'm personally very surprised and very impressed with the ability of these models. So for me, the moment of epiphany with the language model was actually with the GPT-4, where I saw how powerful this is in actually reasoning tasks. Now, look at the simple task of like inductive reasoning, where it says if A is bigger than B and B is bigger than C, what can be said about A and C? And if you look at the different models, so here is ADA is instruction tuned, so it's not able to answer the question. Here is GPT-4All with 7 billion parameters. The same answer, it just does say gibberish things. We cannot do it or just say it's wrong stuff. But you will see as the models scale, suddenly it is able to perform logical reasoning. So here is with the Babbage, and you can see that you can say C is bigger than. That's actually small. So C is bigger, so it's actually small. It's also wasn't able to. But look at this one. So it's GPT-4All. 13 billion model, which was able to capture the correct answer, right? So it says A is also bigger than C. So and then if you go to ChatGPT, GPT 3.5, it's very well aware of it. It even knows it's called transitive property of that logical reasoning and all that. So you can see that has a capability to really understand the logic. Now the question is, if it has a reasoning capability, we want to be able to use it for understanding of what should I do in the real world, like how the world works, and help me understand it and help me make a good plan. So we'll go here, show you some other aspects of a mathematical model. So now that we know the language model can do reasoning, let's look at an example of a simulation. So look at this example. So we're talking about building a mathematical model. So it's a very simple case. It's very interesting from an example standpoint. You see from all day we talked about it, nobody actually, this is kind of a new application of this type of model. Kind of, we looked at the retrieval stuff. We looked at I have a pandas data frame. I can kind of formulate a question. But if I tell them I have a, say, 200K stock portfolio, and I'm going to take 4,000 a month out of this stock portfolio, so sell it. However, my remaining portfolio grows at 4% per year. How long it will last? So imagine, like, you make some money, and then you want to go a sabbatical or something like that. You want to see how long that 200,000 lasts, right? So if you give this question to ChatGPT, GPT 3.5, you see that it's making a very mistake. It's hallucinating. So basically, say, it will come say, assuming the market growth is 4%, so that understood. Then it says number of years equals to portfolio value divided by annual withdrawal. It's basically garbage. And then it says 11 years. It's fake. It's not true. If we use this to GPT-4, it's the same question, you would see that it actually picked up a formula. It says to calculate how long a 200,000 lasts, we need to look at the future formula for future value of annuity. So it picks up a formula, it understands the value of it. So it's a future value portfolio and all that, and it says it puts a number there, but it's actually making a mistake. This formula is when your portfolio growing, not when you're withdrawing from it. So this formula is actually wrong. So we can see that this kind of be this zero-shot type of formulation. You can kind of follow the mathematics and all that, but still, give you 206 months. So it's like it's totally wrong. Now, surprisingly, if you ask the same question to say, write a Python code for the above question, then you can see that it's able to actually understand the reasoning when you answer the code question. So it says, okay, to answer that question, I have a monthly growth rate, writes a formula for it. It says I have a portfolio balance, which is the initial portfolio. And then you see the reasoning, you see the logic is happening. So it says wide portfolio balance is more than 0. Balance equals to the previous balance plus the growth rate minus the withdrawal. And then it starts doing this calculate the month. If the portfolio is not 0, keep going, and then it reseeds it with the values. And this is actually almost the correct answer, except that this formula here is wrong. Now, if you give, so because like this should be basically monthly growth rate equal to annual growth rate divided by 12, something like that. Now, I have a bunch of other examples of this. So you can see that this is a very interesting story happening. So I ran this code 4 times with different scenarios. One was I'm asking it to, so you see the generated code I put in Replit to kind of show you the execution of it. Now with the inflation alone, so this is basically with growth rate alone. You can see this logic here. It's explaining, again, it's calculating the monthly withdrawal rate. It calculates remaining balance, and it picks up the monthly growth rate. And if I run this, so I can show you here. I say, so it would say it's 4 years and 7 months it will last, right? I can then add more complexity to this. So I can say, now go and solve this problem with, assume that there's a rate of inflation. So your expenses are also increasing. Now, I have actually a prompt to this. Is basically, it says the same question. It says, also consider that inflation exists with the rate of 3%. Now it generates the same problem. You can see that in this logic, it covers the for loop for the balance decrease, and it calculates the monthly inflation rates correctly. So you can see here, it says it understands that inflation will increase the prices. We calculate the monthly rate, and it says the withdrawal should be added to the rate of inflation. So if at 4,000 I take now, in a month I'm going to take a bit more, which is 1 plus inflation rate times number to the power of the months. So it could actually does this model very well too. But now we add another complexity. Right? I asked ChatGPT to say, if my balance went to 100,000, so I'm taking my money out. When it gets to 100,000, I freak out and start finding a job. I work for part-time, for $1,000 a month. Now tell me how long it takes for me to finish this story. And you can see that when the complexity becomes a bit harder, now it totally make a mistake. So now it's defining a variable here that it didn't solve for it. That now creates an adjusted withdrawal rate outside the loop. It doesn't even use it. And then you can see things like that where, so if I put, run this again. With so this is one of the it says 4 years and 11 months. The same problem, just another iteration of it. So just like the effect of the temperature. If I look at the 3, it compiles a code that's basically goes to the infinite loop. It's a mistake, right? And if I go with the number 4, it generates, it says 4 years, 4.83 years, which is not the same as 4 years and 9 months. And you would see that it basically, the reason, so the 2 and 1 was also generated, but one uses this formula for the inflation rates and all that. The other one uses a different formula. So it's just an example of, you can see the limitations showing up, where if you wanted to do this type of ask a language model to generate for us a simulation environment or simulate us a phenomena in real world, that's how we would have struggled. And as the more it gets complicated, it actually becoming more and more difficult to kind of translate that reasoning into a code even. But fundamentally, these models are actually quite easy in the sense that, you have an investment, you take money out, you put it into this bucket, and then other these buckets come out of the expenses. So what we need to do fundamentally to model this is basically keep track of flow of money between these buckets, and then each of these buckets are exposed to a certain market condition. So if you have a stock market, it expands with the rate of the growth of the stock market. If you have a house property, those grow with the rate of the real estate markets. Expenses grow with the rate of inflation, and so on. So modeling this mathematically is actually not very difficult. So we can actually build this instructions by hand with the rules of physics and all that. Now the question becomes, now I have a model that has many bells and whistles and all these kind of conditions. How can I expose a person to interact with this model, especially if that person is not a modeler themselves? And this is where I think the most value of ChatGPT comes in, or the language model comes in, where the task of the model is translate for me. So I'm going to come here. So basically, translate for me from natural text to a mathematical model. It's like basically follow this loop. However, make it also very easy for me for user to understand. So you ask the language model to explain to you the mathematical model, and then you talk to it, and then the language model translate those questions into the mathematical model world. So basically creates a bridge between a complex system, similar to what you saw with the a Python, like a data analyst type of question, right? But however, we have this kind of interface model. So I can show you how I basically did this system with this plan flow, which is like some sort of like a no-code tool product, which you can go and try yourself. Now, to do this process, we have basically this story here that I told you, right? So we have a language model, we have a financial model, a digital twin. It's written in code, written by hand, because we know the physics of the system. We can just like, we literally put it in. And then you have an intuitive UX. It's basically you want to be able to interact with it through diagrams, through charts, through text, natural language. And then you want to basically connect these four things together, so users don't need to know Excel. So let me show you a concrete example of how is it done. So we look at the first example is this concept of, yeah, so let's look at this one, right? So I want to basically talk to my software and it builds me a model. So look at this example here where we want basically go from a natural text to a mathematical model. So in this case, I'm telling him, for example, a prompt like this. I say, you come to the, let me show you how the app is actually easier to see. So this is when you come to the Plan with Flow app.planwithflow.com. You see this welcome screen. You can say, describe your income, expenses, assets, and liability in plain language. And then you just type in, you say, our household has 2 incomes. We have a mortgage of 500K, has an interest rate of 3%. I have a car loan. I have a house. I spent $200,000 on living, $2,000 on bills, travel, and we have a stock portfolio of 200K. So just explain what you have. And then what we do here is that we send this text to ChatGPT API, and we get a named entity extraction. From that named extractions, we go transfer it to a domain-specific language in order to communicate with the mathematical model. And then we have a mathematical model that's written in JavaScript on the client side. So now in this case, let me start from a mathematical model. So mathematical model, as I just told you, is basically a couple of thousand lines of code, which does this relationship between these bubbles, right? So you have basically incomes, you have expenses, you're contributing to various loans and retirement portfolio. So you just put it in. It's like literally cash flowing through these arrows. You just need to keep track of numbers. And you have a house increases with the real estate rate and so on, portfolio with the portfolio rate and so on. Now, in order to construct that, we have actually a particular domain-specific language in which talks to the mathematical model. So you basically keep track of every element on this canvas, and we keep track of every financial data in that canvas. And so basically you say, oh, I have a cash box, I have an income, I have an transactions, and each of them has a particular property of themselves. Then you would get something like this. So you can see that out of that prompt, we do an empty extraction and we draw this canvas. So you can see here, you have, so for example, a portfolio of investment portfolio. You could say, I'm contributing 1,000 to it per month, and these are the information that was not in the prompt, but we can add to it, and that becomes the rate of growth of the stock portfolio. You have a cash, now your cash is increasing with this rate. You have a mortgage, your mortgage is decreasing with this rate, and so on. Your car loan is decreasing. Your expenses are increasing with inflation. Your incomes are growing with the rate of growth of income. You can imagine you can put it as a parameters and all that, and the model solves this. Now, in order to do that from a sentence to this canvas, to all these items, we basically have to cross the bridge between these. Basically, we need to build all these. And here we have lots of parameters and lots of properties, and we have basically a 180 number of them, because for every month we need to keep track of these. So it's actually impossible to fit it into a prompt of the language model. So then we will basically create this kind of intermediary step, which is could be just a description of these assets. And in this case, we want to basically instruct ChatGPT to extract for us all the details here. Like, for example, we say, given this text, extract this values. What's the mortgage? What's the car loan? What's the expenses? What's the income? What's the real estate? And what's the portfolio assets? So we use basically some sort of a prompt dynamic, and I can show you how it works, how the prompt works. Where is it? This one, right? So the prompt is something like this. It says, you know, you are a named entity extractor, extract financial information from this text and put it in this JSON format. So in here, now we use basically ChatGPT as a named entity extraction API. And however, it has an ability to basically, the advantage is that it can run very fast. So it can be developed very fast. So for me writing this code, it's basically much easier than maybe finding or fine-tuning or deploying a language, another named entity extractor. It performs probably worse than a fine-tuned model for this type of extraction activity, but it's also it can handle open questions very well. In this situation, I'm actually instructing it to basically find each category for each object. I'm telling him that each of these categories could be monthly or annually. I can tell him that the categories are certain values, and then I can give him instructions on if you couldn't find information, you know, put it as null. Strings, make sure this is valid JSON strings. Put the numbers as such and such and such, and then I give him a few pre-shots examples of how it should be. Give him a sample text. Here would be the correct response. So this is about 2,000 tokens for this extensive prompts, but it would work quite a bit. And then you say, now it's your turn, extract this, and then it would basically output like this, a JSON string. And then you have a Python code which basically parses JSON strings and then translate that to that domain-specific language that you saw. And then that could be ingested with a mathematical model very easily. So we basically we don't need to cross that entire prompt. We don't need to use that entire tokens for the very large model. Another example I want to show you is similar in a similar pattern, but you would see basically I want to do with the natural language prompts. I want to set the parameters to this app. So imagine in this app here. So I was thinking of how do I do this? So imagine you want to change the rate of inflation in your assumption. You can kind of come in and I actually don't have it here. You like if you think about, I want to tell him I want inflation to be a certain amount for the next 5 years. Then inflation changes over time. So that's the assumptions that you might have. We want to stress test it. You can say, well, what would happen if there's a 20 years high inflation, 10 years high inflation in atmosphere? What would happen to my portfolio? What would happen to my retirement portfolio, and so on and so forth. Now, if you want to build an interface for this, we should have built lots of buttons, like a select box, put text, create durations, put charts, and all that. It would be very complicated. We want to basically do something very simple. We want to say, I want to build an interface. Let's just say future inflation is, whatever, 8%. Right now it's like 8% for the next 2 years. And then drops to whatever, 3% the next 20 years. Basically, your economic assumption is that inflation is going to be high for a few years, and then inflation is going to go down. And again, we do in these situations, we don't do named entity extraction. But what we need to really do is to basically construct a vector of inflation over all these months. So we actually need to, there's certain mathematical operations that we need to do here as well. So basically, we want a curve like this as an output. Every month, we want to say, okay, inflation stays at 8%. And for 2 years, after 2 years, becomes April 2025. Then it drops to 8%, and then keep going. For this task, we need to do a certain translation here. So the prompt, again, we have a dynamic where similar, I just explained to you, with a short form DSL, domain-specific language, a long form DSL, and a mathematical model. So what's our mathematical model needs a vector. Our long-term DSL would be, long form is basically all these values, inflation, income growth, stock market growth. As a vector, we want to create a vector very long to be able to read from this and put into the model. Now, to do this, again, it doesn't fit into a ChatGPT's output. So we basically create this type of format where we say, follow the dates and tell me when inflation changes. So in this case, we have a more complicated prompt here. We say inflation will be 8% for 5 years and then drop 1% each year to 2% and remain for the rest of the 20 years. So you can see here, this is a moment where typical named entity extractors would fail because you can extract certain points, but you actually have to internally have to do it. The language model has to do a certain logical operation to kind of say, it will drop 1%, now it goes from 8 to 7, now from 7 to 6, and so on. So the graph is like this, right? So it would say, basically, it stays for 5 years, then drop 1% each year, and then when it gets to 2%, it kind of stays like that. And you can see that ChatGPT 3.5, GPT 3.5 is able to extract it very well. And then what we construct it to is basically extract these date changes. We just tell the prompt to say, extract the date change and put it into this format. So 8% as the next year becomes 7, 6, 5, 4, and then after at 2033, it remains at 2%. You can see the prompt. I'm going to show you the prompt of it. Kind of basically prompt engineering stuff. But it took me a while to basically do some experimentation to kind of come up with a good format and be able to drive it well. But it could be quite powerful for people who want to build apps and want to build apps very fast. So the text basically says, given this text, find the data change within the string. Put it into this JSON format. The data string inflation numbers. And we say the dates should be a certain format. And these are the problems, because if you just say some random thing, you don't describe carefully what exactly you want, then you're at the time of parsing, you get into problems. But if you specify carefully, it would be. So for example, we say no percentage sign, just put the number, just output the number, put it into quotation, so on and so on. And then the examples becomes, you say for April, inflation will be at 6%, then it drops to 4%, then you give it an example. So 2, 3 examples with whatever twists and turns you want to imagine. And then with these few shots, it would be able to produce quite a good output at the end. So that is another example here. I'm not sure, do we want to answer any questions? Happy to stop at that point. At the end of the day, I think I want to show you the third thing, I think. Amir, do you want to ask a question?
No, I just wanted to check in. Do you have more material left, or do you want to move on to questions?
No, maybe 5, 10 minutes. That 5 minutes should be the last example of this. Okay. Now, we did a good interaction. We did it kind of show you how to basically go from a natural language to the mathematical model. Now, what if I want to ask questions about the mathematical model? So I want to probe it. Now, I think, so in this case, if you look at this app, we looked at this concept where I'm going to unzoom. Yeah, perfect. So we said the natural language, you draw a canvas, the financial models running in the background, I could change inflations and so on. Now I can click on these and then inspect the model, how it's performing, I can see. But now I can ask questions. I want to say, for example, imagine in this situation, I want to buy another house. I just have a house, I want to buy a vacation home, something like that. So I can say how much cash I have. How much cash I have available in a year. Available with a typo. In these situations, the model, if you think about it, if ChatGPT would have never been able to do it, because ChatGPT doesn't know anything about your model. Now, in these situations, we need to tell ChatGPT what their mathematical model says. And then ChatGPT parse that information, similar to what you saw with the retrieval, with those embeddings, and like, here's a paragraph, and then now it tells me. So you can see in this case, it's according to the given data, your current available cash in 2023 is 3,000. In 2024, it will go to 8,000. You can see it's increasing slowly, and that's how in a year I'm gonna have 8,000 in the bank. Now, the way to inform ChatGPT what's happening, there's no way except within the context. So what we need to basically send information from a financial model to the ChatGPT. So you saw an example of the Lang chain. We adopt the same model here. But what we do is that we generate a summary of financial information and then give those financial information, could be certain details, to ChatGPT. Let me show you how the prompt looks like. And then we chain all these prompts together. So here's what ChatGPT sees when I'm asking a question. So you can see here's the details of ChatGPT messages that we send to that API after I answer questions. So user says, user answer questions. Assistant says answer certain things, but always before. So this context could be very long. So some of the old history of chat gets deleted every time we send a new message to ChatGPT, because if it goes out of the context, we want to have older messages to get out. What we really care is this last messages. So the person says, "Can I buy a house?" This is a different example. And before answering this question, and before the ChatGPT responds, we also embed this very long text as a user, or could be as assistant, into the ChatGPT flow, context flow. So we say, remember the following financial summary in your future responses. And then we list all these details about cash flow summary, about current income, your future income in 1 year, in 5 years. We summarize the balance sheet summary, what assets you have, what's the dynamic of those assets. We talk about future death payments. We talked about liabilities you have, available cash, and net worth, and so on and so forth. And we send this information to chat to basically part of the context. Then in this situation, now ChatGPT is able to extract information from a financial model into our conversation. And then, so I don't need to kind of inspect the financial model if I don't need to, or if I'm just like novice. And this situation, so I'm asking a question, for example. Now let me show you how I'm using the reasoning capability and knowledge of ChatGPT. If I ask him, for example, can I buy a home worth $100K in a year? So that's type of a planning. Now, this is where I'm going to learn information about what it takes. Let's see what the response is. And this API is quite a killing. The speed of the. Okay, so it says you can see that this is where we're using tapping information of the ChatGPT to determine if you can buy a house. If you put 20% down payment, you need this much. Based on data, your monthly income is this, your monthly expense is that, and then it says you have $8,000 left. You can't put the $4,000 debt payment, but it tells you about, for example, it tries to do certain calculations. It says you can afford monthly mortgage payment of $7,000. And so on. And then you can ask, for example, what qualifies me for the mortgage? It tells you about debt to income ratio. It can calculate the debt to income ratio. And then so you're basically going to go in and then talk about what it takes to get a mortgage, what areas I need to think about. And those are the questions that ChatGPT can answer very well. And then with those information, you come in and then say, okay, well, let me adjust my expenses. If I, maybe if my expense is not 2,000, if I reduce this to 1,000, what will happen if I change my stock portfolio? Financial model gets updated again. So if you ask another call here, so imagine in these situations, we say, now we don't spend to our retirement portfolio, we just save for we're going to save just for the house. In this situation, I have my cash is increasing much faster. And if I ask a question again, now I will be able to answer with this new information because I'm always updating that context prompt. So that's kind of applications. I hope that this can inspire you to kind of think about some of the applications you can build with this back and forth a model similar to what you saw with the Lang chains, but connecting these mathematical models with ChatGPT. It's quite interesting. Tomorrow I will be want to do some participate in the hackathon. So if you like to build some auto GPT where you can kind of ask him, physical answering to build me a mathematical model of like throwing a ball on Earth, and then answer questions, say, what if I go to Mars and throw this ball with the same strength? How do you solve it, right? So it has to make a reasoning, it has to encode the physics of the system into the thing. So these are the things I like to experiment tomorrow. If you're around, let's form a team and let's hack together.